Okay, thank you everybody for joining today's webinar. It is my great pleasure to host Dr. Clara Antón Fernández from Norway today. It's been a few years since we met at a conference and Clara talked about her SiTree project, and I was really excited to see the paper come out and decided it would be great to have Clara talk about this. Before we officially get started, Clara will give a presentation followed by a question and answer period, and we will wrap up the official part by 9:30 a.m. my time here on the West Coast, so in about an hour. But if there are lingering questions, Clara agreed to stay on for a few more minutes, like we've done for the last webinar, so that we don't have to completely rush through everything. And so I would like first to acknowledge that I'm hosting this webinar from my home in Port Coquitlam, British Columbia, which is located on the traditional, ancestral, and unceded territory of the Coquitlam First Nation. And I thank the Coquitlam who continue to live on these lands and care for them along with the water and all that is above and below. I also remind everybody that the webinar will be recorded and will be posted on the IUFRO webpage. And I'd also like to acknowledge, that the webinar is part of the 2022 Forest Mensuration and Modelling Chats, which are organized by IUFRO Research Group 401, Forest Mensuration and Modeling. We have one more upcoming webinar in June, and we'll take a July-August break and continue with the webinar in September, and I'll talk a bit more about that at the end. If you do have speaker suggestions, please email those to me at bianca.eskilsson@ubc.ca. As this is an IUFRO event, I would like to highlight IUFRO's mission to advance research excellence and knowledge sharing and to foster development of science-based solutions to forest-related challenges for the benefit of forests and people worldwide. The webinar series is being organized in the spirit of knowledge sharing and to allow for some interaction and networking while very few in-person meetings are being organized due to COVID-19. And now that I've covered the IUFRO requirements, please help me welcome Clara. Clara, you should be able to just share your screen and kick me off screen sharing, I think. Does that work? Stop share.
There you go. Now it should work in a second. Can you see my screen now?
Yes, thank you.
Okay, perfect. So thanks, Bianca, for inviting me and everybody for being here at basically weird hours probably in your country. I'm here to talk a little bit today about the SiTree and how you can build your own single tree simulator with R, in R and nothing else. So first, if I get to the right place, there. I would like to talk a little bit about myself. So my name is Clara Antón Fernández. I'm raised and born in Spain and have spent most of my scientific career between USA and Norway. For the past 11 years, I have been working at the National Forest Inventory Department here at the Norwegian Institute for Bioeconomy Research in Norway. And a big part of my work here consists of designing, developing, and running forest development simulations for Norway. I do that for both research purposes and also as per request of the Norwegian government to inform the decisions. So when I first arrived here almost 12 years ago now, I came here and there was a magnificent data, that is the NFI data, and very little done for the last 10, 20 years. So they were using a stand level model for even age forest, using data from permanent plots. And that works well for well-managed forests, but the majority of forest in Norway is not well-managed, unlike Swedish forest or Finnish forest, if you know a little bit about them. So we're there, we need new models. The models are like, so the model maybe is from the 2000. The models were from the 70s with data from the 50s. So we definitely need something new. And we knew that because we basically did have an even age forest and mixed forest, we need individual tree. Right, so we sit here where Rasmus Astrup and I basically this 12 years ago, and was okay. We need a single tree level. We we are a rather small institute if you compare us with our neighbors Finland or Sweden. So we didn't have on staff programmer that we could use to program our own simulator. So we needed to build it for ourselves. And we thought that R could be a solution because I knew R. My statistical modeling and all the data analysis and everything that we do it in R. So okay, that was a natural choice. And it was pretty well developed by that point. So we came up with building our own single tree simulator in R. So we built SiTree. SiTree is a framework to build individual tree simulators. So it's not a single tree simulator by itself. It's just a framework. If we use the analog of a tree, so a tree have different parts like the roots, the trunk, the bark, the crown, and the tree needs all of its parts to be able to survive. And each part has a different function, right? So in a similar way, an individual tree simulator needs different modules. For example, one module that grows trees, one that kills trees, and one that regenerates trees, and one for management. It also needs data, of course, to be able to run. But SiTree in this analogy will be the trunk, right? The thing that pulls everything together, the one that does the bookkeeping, that makes sure that everything communicates and transmits information. But the trunk provides a structure and communication, but it's not a tree, right? It needs roots, it needs a crown. A SiTree needs this growth management and a death submodel function to become a single tree simulator, right? So SiTree per se is not a single tree simulator, it's the framework to build one. But right, this is what SiTree is. You need the rest of the stuff. So how do we build a single tree simulator? You download and install SiTree from CRAN the same way that you do every other package. Install packages, SiTree, you load it, you run your example, and it's working. But this is just the beginning, right? We need to build our own. This is just an example that is running. And my suggestion here is that you start with the example. But let's step back a little bit and talk a little bit about the structure of SiTree. So what does SiTree needs? SiTree needs tree data, it needs plot data, and it needs the functions, right? These parts of the tree that we have talked about. For tree data, it's required basically 4 columns. One would be your plot identification number. So you have several plots, to which tree every plot belongs. You need a tree ID that needs to be unique. You need 2 numeric quantitative variables that are called DVH and height, but you could grow DVH and crown or whatever you want. And these are going to be developed through time. And you have a 5th column that is I call tree species. You can, because it's the most logic, and that is not going to be developed through the simulations, right? So tree species doesn't change, DVH changes, and height changes. You also need plot data, which you can give as a data frame or as a list, and the only requirement is the plot ID that needs to match the tree ID. And in the plot data, you can put vegetation type, stand age, management history, or whatever it is that is important for your own single tree simulator. And you need to pass the functions. Right, so a typical call from SiTree looks like this. Right, if I can get the thing to there. Right, so here we pass the tree information, stand information, and here are all the functions that are needed. You need one for growth, one for mortality, one for recruitment, and management. You can either pass it or pass it as a null. The same for tree removal, right? So the functional management is management at the plot level. Here, this function decides if you're going to fertilize it, or you're going to thin it, or you're going to final thin, or you're going to do some continuous cover type of treatment, or any treatment, right? And the tree removal decides if any of this management includes removal of trees, then you need to pass it which trees exactly are going to be removed. And this is the function, you do it there in this function, in the tree removal function. And then there is a modifier, which I would include there modifications of site index with climate change, for example, fertilization, things that let's say occur on top of the regular management and growth, like things that change, for example, site index. And there is this function for preparing common variables, which is meant to be used to calculate the typical variables that you're going to use in the rest of the functions. For example, base area of larger trees, quadratic mean diameter, mean height, lower height, all these sometimes long list of variables that you use. You calculate it there, you calculate it once, it saves time and memory. Then another mandatory thing that you need to pass is the number of periods that needs to run and the period length, right? So if you have 5 years as a period length and 12 years, you're going to have over 50, so 60 years of simulations. And then you can pass anything else you want. If you want to pass harvest levels, or you want to pass any other information, you can just keep going with this list and comma, next thing, and you can retrieve it afterwards to use. Okay, I'm going to give more practical examples if, yeah. And actually, I mean, I don't know, there's a lot of people, but if you have questions, I will be happy to take it as we go. So I don't lose people in the middle of the explanation. So the next part would be like, so we have all the data, we have functions, we go really into SiTree. First, it checks if you have a modifier function. If you do, it runs it. And if you don't, it goes to prepare the common variables. Then would be the management, which will run first the stand level management and then the tree removal part. This at this point, it only calculates things, right? So it doesn't apply anything yet. So your tree list is the same as it was at the beginning of the simulation. Then it calculates growth, mortality, and recruitment. And recruitment includes both planting and ingrowth, natural ingrowth. So anything that creates, that adds new trees, right? And then all these things that you've calculated are applied. First the growth, then death, then the removed trees, and then the recruitment. And we get to the last part where we ask, is it last period? No, run it again. If it's last period, it gives you the output. The output is a list of all live trees ever in the simulation, a list of dead trees, a list of removed trees, together with plot information, plot level information. So you have the data of every tree that was live, dead, and removed at any point, and at which time, for example, death happened, and at which time they remove when it was removed. Okay, so when you get the output, it's a list with these elements. Each element, live, dead, and remove, it's a special class that I've developed, which is a reference class. And I mentioned this because they are different from your typical object in R. So which the typical objects in most of the models are called S3 and S4. And usually when you, and they behave in this way, when you modify them, they are copied in memory, right? So that takes time and your RAM will go nuts very fast if your data set is rather large. And I use this for running the full NFI with our several 100,000 trees. So I needed something memory efficient. I cannot run 100 to 100 year simulations with a large data set with the typical R object. So the reference class are a little specific. So they do this no copy or modify thing. So when you modify it, it doesn't copy it. It has a little bit odd behaviors for some things, but for most of it, you're not going to feel any difference. Just going to be very memory efficient and it's going to be faster. A typical list for, this is a live tree list, looks like that. It's very contained. It's smaller than if I would use a data frame, and it helps me to get sure that it's consistent. So SiTree will do the big bookkeeping. We'll make sure that the trees that need to be added are added, that the trees that need to be dead, they are removed from the table and put in the special dead trees table, and that the trees that need to be removed from harvest, like they were harvested and not dead, they go to the right place. So you can find all the data in the right place when you need it. Okay, let's start with the fun things. Where to start? So this is our typical, our example tree, right? Our example single tree simulator. And we need to do it our own. I want my own functions there, not the ones that I gave as example. So where do we start? my strong suggestion would be to start with the working example provided, because it's the easiest. Right, so this is the typical SiTree call function we've seen before. So let's start by switching the mortality submodel. I want my own mortality submodel. So we go to the call and say, okay, there is the mortality call. I'm going to change mort Bolland source 2007 by my own mortality function. So if we look inside this function, we see two things, important things. So how it starts, this is the things that how your function is to look like, and this is what is going to output, right? I need the list with true or false. If you don't want to go through here, you can also, there are two vignettes for SiTree. One that describes the more of the technical things, and the other that describes examples, right? And that gives you examples to work with, and they are all available at Gran. Okay, if you go to these vignettes, you will see that the NF mortality, the function for mortality, should return a true-false vector of same length as the number of trees in the tree list. True indicating dead, okay, and false alive. So only that tree should be true because it's a mortality function. Okay, so what I'm going to build is a 8 and 2, so it's an older mortality equation, and I want to see the difference between using this function and the newest Bolland source 2007 equation. So as you see, I use the same as before, so this looks exactly the same as, if it's not there, right? So it's the same, their function, their FL, common variables, this period is going to be the same as here. And the result is going to be the same. So, okay, same beginning, tree data. So for this function, I need DBH, or initial DBH of the tree, and I get it from the tree data level. So I will want to go tree data. I want actually to access the data from that object and the DBH in millimeters for the current period, which is called this period. Now I have initial DBH in millimeters for all the trees in my tree list. Base layer of larger trees, it's calculated in common variables because I knew I was going to use this variable. And I just read it from common variables, PVA, blah, blah. The same for the species group, because all species are classified into spruce, pine, and birch. And I need that to know which parameters I'm going to use for which tree. And I read it from there. The same for the proportion of spruce in the plot. And the same for the set index in meters. Actually, it's from the standard information. And the next part is the parameters, which I copy from their paper. And it's a logistic equation. So I calculate the logit according to the equation in the paper. And we'll calculate the probability of mortality. And this is going to be a stochastic approach. So I'm going to compare it to a random uniform of length, the same as the DBH. And it's going to be true if my number is bigger than the random number, and false if not, right? Okay, so we have our new mortality equation there. So the only thing we need to do is go there to our call to SiTree and change the B 2009 for our ET 2001. And we have our new tree with a beautiful blue crown, a little piece of blue crown. So there we have a modification of the initial example of the individual tree simulator. Okay, let's do something a little bit more complicated. Let's switch the growth submodel. So the growth submodel, so we changed our mortality function, and we want to change now our growth function. If you go to the documentation, you will see that FN growth should return a data frame with two columns, giving diameter increment and height increment of all live trees. And they need to be numerical, and they cannot be NAs. Right, so what I do is, because for me it makes sense, I created basically a wrapper around a DBH increment function and a height increment function. And because this is not built in SiTree, what I did is pass it in this in the ellipses, in the other things that you pass to the equation. And this is this thing below. DBH increment. So that's my function for DBH increment and my function for height, which actually doesn't calculate height increment, but height at second point, and then you can calculate from that the height increment. Okay, so we do the same thing as before. We go to this grow DBH increment function. The initial part of the function, it passes the same parameters basically. And then you have a part for, this is the way you get the things that are passed in here, right? In this part, the way you retrieve it in your function is list of ellipses, and then I just call it others because yeah, it makes sense. And then I have here the name of the function for DBH increment and the name of the function for the height increment, and I call them here, right? So actually, if I change this name, it will automatically change things. The function that is used for calculating diameter increment. So here, the only thing I do, apart from calculating DBH increment, is making sure that the tree doesn't go below 50 millimeters, which is 5 centimeters, which is the minimum DBH for the NFI. Right, so we go there. We look into our DBH increment function. This first part looks exactly the same. This part looks exactly the same as. Sorry, let me.
You're on mute, Clara, somehow.
There you go. Better? Sorry,
Yes.
The thing appeared in the middle of the screen, so I had to move it and I click correctly. So thank you, Bianca. So the DBH increment, the original one, the example, is this first part is exactly the same as before, and it returns an integer of the DBH increment. And I suggest you use also an integer and a small unit, because it saves a lot of memory if you don't use decimals. Integer occupies much less space in your memory. So okay, let's change.
I can't hear you anymore. Something happened again. I can't hear you. Yes, you're back.
Me?
Yes.
I'm back. Okay, good. So okay, let's what I did for this DBH increment was come up with a very fast CAM model and very bad one, but just for the sake of showing here things. So the way I pass it is I change the name of the DBH increment function, but I also need to pass the model because the SiTree doesn't know anything about my model, right? So I just add it to the ellipse part of the function, right? There is my model, which I built really fast. The function starts the same way as the other one because that's necessary, because the function is going to try to pass this element. I retrieve my model using the ellipse thing and the others. I build a data frame with the information I need, and that will be DBH in millimeters. And the same way from the tree list, I take the data, DBH millimeters from this period. Citing the spruce is taken from the sun level information, and the same for sun basal area and point basal area of larger trees. This function actually predicts basal area increment, so I had to convert it to final basal area, then the DBH final, and then I can calculate the DBH increment in millimeters and pass it as required by the function. And then I modify it, right? So now we have the new mortality function and a new DBH increment function, right? These are three things we've modified, and we have a beautiful, colorful tree now in our own single tree simulator. Okay, so let's take a little bit look at what's the effects of changing these things in the simulator. Okay, so we had the original single tree simulator. We had the one with the mortality, and the one that with the GAM model for the DVH increment and the mortality as the models. So there is, even though all the information in the output, it's in this special class because it's just very tight to work with it. There is a function which converts SiTree format to data frame, and you can use to convert it to something that you are much more used to. So I convert all this information from the live trees from these three models into a data frame. I bind them, and I calculate the standard base area average, sustained base area of the stands, and then I calculate the average, and then we can take a look at it. So this is just basically average base area of the stands of the 100 stands that I have, using the different simulations, different simulators. So we have the original one. You see that when I change for the mortality function, the average base area increases quite high. That's because it really predicts much lower mortality, and you have the results for when you change mortality and the GAM model, and that you have in a higher base area. And that's basically because I use spruce growth for all the three species in my quick fix. But that's how you can take look at results, and there's many things that can be done, right? So I, for example, build and I make it available, so you can use the same approach to calculate the volume for the three species that are in Norway. And then I can very easily and quickly, with a couple of lines of code, calculate volume increment. And it's very easy for us to switch and try different things. So we turn out that the growth models stay more or less stable, but we do a lot of changes to management and try different management things. And actually, even though this looks quite easy at this point, I mean, like quite straightforward, and maybe you don't see the capabilities. You basically can do anything. Like it takes a little bit more work sometimes, but you can, for example, so one of the questions that we were asked by the viewers was if you can do like planting and like say grow the stand from planting the trees till they reach the 5 centimeter limit to show up in this type of inventory. And yes, it says for when you don't have a tree list, then for us would be plot level information, and that you can develop, for example, in the plot comparables, because it's things that you are going to change on or in the NFM modification. Then you modify the number of plants until you reach the point where they reach 5 centimeters, and then you have to create a tree list, and then you add it, right? I've made modifications for climate change. We have fertilization implemented. I don't know, it's just almost everything and everything you can think of, I've done it. And I'm happy to share and to the code I've created for the different things. And I'm also happy to help most the people to build their own simulator if they have a question. But I think that the easiest way is to start with an example and start changing the submodels one by one. If you want more resources, where to look for more information, this is the paper that Bianca talked about, which describes a little bit how it works and what it's meant for. And for example, SiTree, I would say if I was a PhD student and I need to build my own thing and I want to test my functions, that would be perfect because you can do simulations, especially if your data is large, without all the bookkeeping that it's much harder than it looks. Together with the paper, we have created called the name a capsule, where you have the code and the data that is used in the paper and that you can run. You also have 2 vignettes that run examples and that describe the inside of SiTree. SiTree is completely built in R. So if you are handy in R, you can modify it yourself to your own purposes. And there's another thing I recommend, because I've been talking to Carl Bigden, which is a PhD student now at SLU, and has done an incredible work putting together all the old and the new functions that are used in Scandinavia, and I think in part also of Europe, which are stand level and individual tree level. And there are like hundreds of them. So if you want to go and test things, I'm planning to work with him and write a wrapper so you could use these functions and test them. But it's beautiful having all the idea actually behind Carl's work is it's a little bit the same as SiTree, right? We want to test different things, we want to test different models, but most of the models are built in things like C++, Java, and they are not easy to test, and they are difficult to get in and code, and some of them are even closed code. So he's trying to reproduce what these old models and current models are doing in R, so he can go and play a little bit with it. And that's about it. Thank you, and I will be happy to take questions.
Thank you, Clara. Before we start the question answer period, let me share my screen one more time. And you should see this to just announce the upcoming webinars. The date for the June webinar is not fully set yet, but Dr. Christian Salas from Chile will be talking. And then we take a 2 months summer break, or I guess winter break, depending on where you are. And on September 27th, we'll pick up the webinars, monthly webinars again, with Dr. Guillermo Trincado also from Chile, talking about growth and yield modeling of fast-grown, intensively managed forest plantations. And the announcements, I've been sending those out via the Division 4 mailing list, and I'll post the link in the chat in a little bit. So please register for subscribe to the list. The webinars will also be posted in the IUFRO calendar for Research Group 401. And if you have any suggestions for speakers or anything else, please email me. And thank you for joining today's webinar. I will send out an email once the recording is posted. And there will also be a report posted that will have Clara's information, and I'll make sure we have all the links that she showed in that report as well. So with that, I will stop the recording.